Hello everyone, welcome back to my channel. Today we have an essential tutorial for network administrators out there, installing SSL certificate on a Cisco router. Securing your network communication is crucial today because we are living in the world of hybrid cloud. Many of the situation we will be integrating our on-premise routers to an internet entity or a cloud entity that will always travel through the internet, and the communication must be secured using SSL and TLS. So let's dive right on it. My name is Abdul Jassim. I'm a unified communications architect, over 10 plus years of experience in Cisco and Microsoft Teams and telephony solutions. Before going to the installation of SSL certificate, first let us understand what is SSL TLS handshake process. Imagine that you have a server here, the server, let's call it as server A. And any server in the world, if anybody wants to establish an SSL connection, any client wants to establish an SSL connection, they should have installed a certificate from a CA, certificate authority, and there are public and private CAs available, but I'm not going to that deep into the CAs part. So imagine in this case, we have a public CA. I'll take an example of GoDaddy. Yeah, GoDaddy is an SSL provider. It can give a signed certificate to everyone. The moment I build this particular server, I will generate something called CSR, certificate signing request. I will send this certificate signing request to a CA. The CA will eventually verify my authenticity and send me back two things. One will be identity certificate. Call it as identity certificates. Identity certificate. And the second one is called cert bundle. So this certificate bundle is nothing but it contains a root certificate and subordinate certificates. Usually a CA will be architectured in such a way that it will have a primary CA and some subordinate CAs. All those CAs will be merged into a bundle and the CA will provide that to us. As a network administrator or a server administrator, I will receive these two and I will install it on my server. This will be the process we're going to be covering today. But even before going there, we will understand what is an SSL handshake process. Imagine that this process is already completed. Then I'm going to talk about how we can secure our communication with the server. The assumption is you have already a CA and a CA certificate is already installed. The CA is GoDaddy. Now, in my case, this client wants to establish an SSL connection to a server. Maybe it is accessing https:// something. The moment it generates that request, the client is actually sending a client hello, which contains TLS versions and the supported cryptographic algorithms. So when we generate CSR, we are assuming that that process is already completed. But the moment we generate CSR, it will create two things. One is called private key and another one is called public key. Private key will be always kept separately. That's always a private one. The public key will be always encoded in the form of a certificate. So your SSL certificate contains nothing but a public key and some cryptographic information and some our CA informations. All right. So that's for our information. And the moment the server receives client hello, it will send a server hello back to the client. The server hello contains nothing but certificate. The certificate will have its public key. So every time the public key will be encoded in the form of certificate and it will send that certificate back to the client. Now it is client's responsibility that whether I should trust this guy or not. That is one portion of the security. The second one is encrypting the messages. So first I need to see whether I trust the server or not. So how do I see whether I trust the server or not? Every entities or every client, it could be a Windows machine, laptop, or Linux, Mac, they will have something called local trust store, which is the kind of folder where they keep all the certificates. In this case, if I receive that certificate, the client will go and check its folder or its trust store, whether I do have that particular certificate. Do I know that server? Server name was A. Do I know the server A? Of course, I will not be knowing that server A, but it will again check who signed or who provided the certificate to the server. So in this case, GoDaddy provided the certificate to the CA, right? That information will be also there in the certificate. So the certificate that I received here will have server information and the CA information. Since GoDaddy is a globally trusted CA, every operating system when we install, it will have that predefined CA certificate, the trust store already installed. It's been taken care by the OS manufacturer. You don't need to worry about that. That means your GoDaddy certificate will be present in the trust store. So since it is a trust relationship, for example, if you have a friend, I trust you and I trust your friend as well because I trust you already so that I can establish same trust relation to your friend as well. So the same way, since I trust the GoDaddy, I trust the server as well. So at this point, they are okay to exchange something called session key. Session key is nothing but assume that the session key is ABC. The client itself will generate a key called session key. So imagine at this point, the authenticity is completed, right? I am trusting the server. Now I am encrypting my messages. That is the next part. So I'll generate a random key called ABC, that's called session key, and I encrypt this ABC with the public key of the server. So how did I get the public key of the server? In the first place, when they send the certificate, it will have the public key called 123. That's an example. And 123 is just a public key example. So I got a 123. That's a public key of the server. I know that. The client knows that. And client generated an ABC. It's called sessions key. And they merge these two together. Okay, they encrypt the ABC with the public key. So the thumb rule is anything is encrypted with 123, which is the public key. Only its own private key can decrypt it. That's called the PKI infrastructure, public key infrastructure. That's all used as Diffie-Hellman algorithm and a lot of other cryptographic algorithm. I'm not going in deep into that, but this is a simple funda. Anything encrypted with public key, only the private key can decrypt it. So if you look at the same analysis here, my ABC message is encrypted with 123. So ABC nothing but is another key called session key is encrypted 123. And I am sending that back to the server in form of client key exchange. And server will receive that. And only in the world the server can decrypt it. Why? Because it has the information about the private key. So server knows what is a private key. So anything is encrypted with its public key, only its private key can decrypt it. So that means only server's private key or the 321 can decrypt it. So at this point, the decryption happens and we get the ABC back. Let me ask one question. At this point in the world, who knows about ABC? My client knows about it because it generated itself, and the server knows about it because it decrypted that message back. So ABC, ABC, only two entities in the world knows about ABC, right? Now, any further messages the clients wanted to send to the server or server wants to send to the client, they will use that ABC key, right? Because it's I know only ABC and the client knows ABC and the server knows ABC. No one in the world knows about ABC, right? So any message which client wants to send to the server, it will always encrypt with the key called ABC. That's called session key. And client will send a finished message and server will also send a finished message. So any communication that happens in between the server and client, they will encrypt that message with ABC, so a session key, right? So that session key is owned by only the client and the server. They knows what is session key. So they can decrypt and communicate back. So this is the simple explanation for PKI infrastructure. Again, there are a lot more into it. Our scope is not that. So we understand how an SSL or TLS handshake happens, right? So in order to do all these things, we should complete this process. So wherever you wanted to establish a secure connection, one example would be, in my example, I'm talking about Microsoft direct routing with Cisco router. The Microsoft teams will be always looking for an SSL connection towards our on-premise Cisco router or the CUBE. We'll talk about that later. That has nothing to do with our specific discussion today because we are only looking at certificate installation part of it. So let's understand how do we complete this part. And before going there, let's see what is the information inside a certificate. This is actually a certificate. To demonstrate that, I will open a live session, a live certificate. This is cisco.com website. And if I click on this particular lock symbol, you can see your connection is secure. And then there is an option called view certificate. I don't like this view. What I'm going to do is I'll save the certificate to my details, export, and desktop. Let it be. I got that certificate in my desktop. All right, so this is that certificate. And if I check this one, I can see this is issued to cisco.com. So anyone who runs that cisco.com website, it is issued to that particular server. and it is issued by Hydrant ID Server CA. This is the CA I'm talking about. They are public CA. They initiates or they provide certificate to Cisco. And if I go to the details, I can see something called serial number. This is used to verify the certificates. If you want to compare two certificates, we can do that. And then most important thing here is called the public key. So this is cisco.com's public key. I can easily see that because it is not a private one, it is always public. So they're going to send that anyone who requests a certificate or the SSL connection, they will send that public key. Any message I encrypt with this can be only decrypted with Cisco's server itself. So now I have the public key. For example, I need to send something to Cisco and I encrypt that message to public key with the public key, only Cisco can decrypt it. That's how it works. And if you look at the certification path, I can see multiple hierarchy level here. This is the server itself. This is called intermediate certificate or subordinate CA. And then this is the root CA. That's how a normal certificate looks like. Now we understand what is SSL TLS handshake process and also what is how a certificate looks like. Let's get into my topology. So I'm going to be integrating my on-premise Cisco Unified Communications Manager or CUCM, which is an on-premise PBX solution or telephony solution, integrating that with Microsoft Teams phone system. Microsoft Teams is a cloud-based telephony solution. So there are certain scenarios where where a customer is already having a CUCM setup and they also have a team setup. There will be a bridge between these two in form of an SBC. We call it a session border controller. The Cisco session border controller is nothing but Cisco CUBE, which is a Cisco 2911 router in my case. It can be any ISR, ASR, or Catalyst routers. Can also run the same CUBE version, and then it can integrate these two things together using SIP, session initiation protocol. Irrespective of the technology or the topology, the way that you install SSL certificate on the router is always the same. The reason for my certificate installation is, if you look at the green color mark, the connection between Microsoft Teams and the Cube is always happens through the internet, and it always requires a public IP address and an SSL certificate. So that's where I'm going to be installing. Your scenario will be different. Maybe you will be installing a VPN certificate, or you will be integrating your device to an internet entity where you need a DMZ IP and then you need a certificate. It can be anything. The installation of certificate in an iOS router always the same. So we're going to be talking about that today. So for this particular one, what are the things required? Access to my router. Then I should have a DNS error code. For example, I will be naming my Cube or the Cisco 2911 router as SBC, and my organization uses a domain name called ajcollab.com. So I should have a sbc.ajcollab.com. Should be resolving to an internal IP address, which is 192.168.0.11 internally in the corporate LAN. The same thing, sbc.ajcollab.com should resolve to a public IP address when I am trying from externally or any external party trying to integrate. That public IP address should be one-to-one NATed to the Cube IP address, which is 192.168.0.11, so that anyone who externally talks to that, it comes to the public IP address, it goes to the private IP address of the Cube so that they can establish that connection. That terminology, we call it as network address translation. And I'm not going into deep into network address translation. So we have a DNS error code for the internal, which is a Windows server, Windows DNS server. We should have a public DNS record, which is for external users. I am going to be using a GoDaddy domain. I purchased ajcollab.com from GoDaddy. And then SSL certificate. I have an SSL certificate from Namecheap. That is a paid one. And there is a zero SSL certificate option also available, which is free. I'm going to demonstrating both. Then like public to private IP address translation, network address translation, depending on the infrastructure, it can be different. But I'm going to be showing in terms of my lab. So let's go and see all these entities. So this is my Cube router or the 2911 Cisco router. So this is the version and this is the platform. Where is the platform? Sorry, it's 2901, yeah. And then let's go and see my IP address. So it is using 192.168.0.11. So anyone internally who tries to access sbc.ajcollab.com, by the way, domain name also I have configured. If you look at that, I have configured IP domain name ajcollab.com. Anyone internally who tries to access sbc.ajcollab.com should be able to reach this particular private IP address. Let's make that happen. I'm going to open my DNS server. 192.168.1.11 is my DNS server. I'm going DNS management. I'm going to add an error code here, which is SBC, and the IP address here, 192.168.0.11. Anyone who access sbc.ajcollab.com internally will be able to reach that IP address. Let's test that. Yes, so if NS lookup sbc.ajcollab.com, I will be able to reach that private IP address of the. Okay, so that's about the internal one. Now, external, how that external communication happens. So if I go to the topology, Microsoft Teams font system sits in the internet, or anyone from the internet should be able to access this sbc.ajcollab.com to its public IP address. So at this point, we will be working with a public DNS provider, which is GoDaddy in my case. I need to add a DNS error code that points to my home public IP address. Type, what is my IP? This is my home IP address, the public IP address. And I will be saying anyone who try to access this, it hits here and then it goes to the internal IP address, which is 192.168.1.11, which is that technology is called NATing. So let's do the NATing process in my home router. This will be varying based on your home router, whatever model you have. Yeah, so let's see how we map that public IP address to a private IP address, which is the public IP address of my home public IP address should be mapped to 192.168.0.11. If you access your internet router, by the way, this process will be different for different people based on your architecture and the infrastructure. It may be different. You will be doing, if it is a corporate environment, you will be doing this on the firewall. Since I'm in a home lab environment, I'm going to be doing this. But again, these are all not required for that certificate installation, but I'm just giving you how I did that complete setup. So go to advanced, then NAT forwarding, port forwarding, and I'm going to be adding service name, HTTPS. Let's put cube HTTPS 192.168.0.11. External IP, external port, HTTPS uses 443, internal 443. And also add one more thing, because HTTPS is one of the communication which I'll be trying from externally. And I'll also be establishing SIP connection towards this. SIP S. Cube SIP S 192.168.0.11. SIP S uses 5060 port number. I have these two entries. This will make sure anyone who comes to my public IP address, which is this, please forward that particular communication back to this IP. If the communication is SIP, okay, sorry, this is not 5060, it should be 61. SIP, secure SIP is always free. Normal SIP is 5060. Yeah, anyone who comes with a 5061 communication with the public IP address, go to my private IP address. Anyone who comes with the 443 to public IP address, go to private IP address. So I'm done with my NAT configuration. This is done, private public IP mapping. This is done. And then access to Cisco router, that's done. Internal DNS record added. Now let's add DNS error code, public DNS error code for a cube router. So as I said, even if I'm outside of the network, when I access sbc.ajcollab.com, it should be resolving to this one. I have bought a DNS name called ajcollab.com from GoDaddy, which is like 100 rupees or something. And if I go to its DNS records, there is an entity here called SBC. It's an error code SBC that uses my public IP address. Again, the same IP address I have given here. And I'm going to hit save. I already saved it, so I don't need to switch points to my public IP. And if I open command prompt in my system, if I use ns pc.collab. Google DNS is resolving that, and it is giving me the IP address of my home router. So anyone in the world, even you may try this, sbc.ajcollab.com will be resolving to the public IP, which is my IP address. All right, that's about it. So we have completed all these prerequisites. Now the time for us to generate the CSR, and then, all right, so now we understand what's my topology and what I'm trying to do. Let's get into the router and then generate the CSR, which is certificate signing request. That is our first process. The router, and let me open the configuration guide here as well. So the first command, crypto key zeroize RSA, will negate all the existing private key and public key which is already available in the router. So if you're working on an existing router, there are chances that there could be a PKI key. The key pair is already generated. If you want to use that, you can use it. To understand what are the keys available, you can use the command crypto my public key RSA. This will display the existing key pair. So if you look at that, you can get the key pair name from here, SBC RSA key, which I already generated previously, but I'll be removing everything. So let's start from the beginning. The first command is invalidating the existing key pair, which is crypto key zeroize RSA. Done. They're asking me to authenticate that. Yes, it is done. Now it's gone. Now if I type the crypto key, my RSA, you don't see any keys. It's empty now. At this point, if you close the SSH session and try to open again, you will get a warning. Sorry, you will not be able to log in at all because the key has been gone. So SSH always need a private public key SSL self-signed certificate. So you will not be able to log in at all. So make sure once you remove the keys, you should initiate a new key and also tag that to the SSH configuration. So let's get into that. Before that, I have a command here, IP name server. So I'm setting up some public public name servers here, which I don't need right now because I'll be able to ping google.com, for example. That means my DNS is working fine. I can resolve external DNSs as well. I'm not adding that. And IP domain name, which I did configure previously. Sure. Section. You can see that IP domain name configuration already in place. Then NTP server is an optional. If you want, there's a Google NTP, we can configure that. But I'll actually start from here, generate key pair. So I'm going to generate a new key pair. The command for that one is crypto key generate RSA general keys label SBC RSA key. That will be the label, a name of the key, and it'll be 2048 in length and exportable. So RSA means an RSA key pair. Let's go ahead and enter those commands. All right, so they are generating the key pair. So right after generating it, I would recommend you to copy this command, IP SSH RSA key pair and the RSA key name. So this will again regain back to the SSH configuration. So what I have done is SBC key pair has been generated, and then I'm going to tell the router when someone accesses SSH, use SBC RSA key. So SSH has been taken care. Now let's go and create the trust store. So like what we discussed before, every entity will have a folder where they keep the actual certificate and the bundle of remaining trust certificates. Okay. So every trust point will be a folder. So let's create the folder for our SBC. This is the command for that. Crypto key trust point SBC trust store. This is the name. You can have any other name as well. Enrollment terminal. This will give us an option to paste the certificate in the terminal itself. Because once we get the certificate from a CA, we're going to be installing that certificate on the terminal itself. We're not uploading through SSH or anything. We are pasting it on the terminal directly on base64 format. So that's what this command does. And then fqdn sbc.ajcollab.com, because every certificate CSR, when you send that CSR to some CA, the fqdn should be hosted on the CSR. And again, the same fqdn will be available as a common name. So that is what this is the same thing. This is OU, which is optional, organizational unit, and organization, that's also optional. Subject alt name, again optional. You can ignore this as well. And serial number, none. Usually the router will prompt you, would you like to add the serial number of the router in the CSR? We usually do not add that. So if I don't have this command, while entering in the console, it'll prompt you, do you want to include or not? If I have this command, it will not ask for that. I'm just entering that in advance. IP address none. Again, this router will again prompt you, would you like to add the IP address in the CSR? So again, we don't need IP address in the CSR. So that's the reason I have done that in prior. Then revocation check none, and then key pair. So this particular trust store will use our previously generated key pairs. That means we'll be using the private key and public key. With this, we will be generating the CSR. So let's copy and paste this one. All right. So trust point or the folder has been created. Now let us go ahead and generate the CSR. To generate CSR, crypto PK enroll SBC trust store. So SBC trust store is having the required information to generate a CSR. So let's go ahead and enter this one. This will give you an option to view the CSR in the console on the terminal itself. So this is my CSR. I would definitely have to copy this, then keep it here. I got my CSR. My next task would be approaching one CA. It can be a public CA or private CA, anything doesn't matter. But we are going towards a public CA because we are interfacing this cube, an external entity. So someone from internet will be able to access this. So that's the reason I'm going to a certificate provider. There are many certificate provider. GoDaddy is one. Then Namecheap, and there are a lot more, DigiCert. So I'm going to show you a free option as well. There is something called Zero SSL that will give you 90 days of free SSL certificate. So if you are experimenting it on a lab or a POC environment, you can go ahead and do that. It will give you 90 days of SSL certificate. Or if you wanted to have a little more robust one, you can purchase something from GoDaddy or Namecheap. I have purchased from Namecheap. I'll show you both options. Once you have the CSR, next task is to go to CA or a certificate signing authority. So let's first approach a free CA provider, which is Zero SSL. So you can create an account in Zero SSL, which is free. And then once you sign up, they will give you 90 days of go to new certificates and then enter your UDN here, sbc.halab.com. Next. And it's a 90-day certificate because that's free. Next. Then you have the CSR here. So paste the CSR. Next. Now these guys will ask me, so I'm going to select 0. These guys will ask me, are you the actual owner of ageocollab.com? Yes, I am. So you can verify through some of the email provided here. If you are the owner of admin.ageocollab, you can. But what I have seen is this email takes a while to get that. So I'm going to using a different verification method called DNS record CNAME. Select that, and they're asking you to add these CNAMEs inside your ageocollab.com domain. So the ageocollab.com is provided by GoDaddy. I'm going to copy till here because ageocollab is your root domain. Copy this, go to GoDaddy account, go to your domain name and then DNS, click add new record, then select CNAME. Name will be this and the value will be this one right here. All right, and keep the TTL default and save. So now I proved to the Zero SSL guys that I am the actual owner of ageocollab.com. So of course they can issue a certificate to sbc.ageocollab.com, which is subdomain of my primary domain. So click next, and they're asking me to verify. In the GoDaddy, the update has been completed. Sometimes it takes a while, but let's try to verify that. All right, so it verified. They're saying your domain has been verified. So we will get the certificate from here now. Let's get that and install it. All right, so go to the default one, then download certificate. Once you have downloaded the certificate, you will see a folder like this. Let me extract that. This is our point of discussion. Let me clean this up. They gave me two things. One is the certificate.crt ending. Another one is the CA bundle.crt. Now we know what is a CA signed certificate, but still we will evaluate a CA signed certificate. So this has been issued to sbc.ageocollab.com. That's right. And issued by Zero SSL RSA. This is the guy who issued the certificate. And of course, I have 90 days of validity. If I go to the details, I can see my public key here. So this will be the public key which my router will be using. And then the certificate path, we have multiple authorities. So there is one subordinate CA1, subordinate CA2, and then the main CA, root CA. So this is one of the certificate they give you. This is called identity certificate. So how do I know this is an identity certificate? Because it is issued to a server. Sometimes we call it a server certificate as well. But the right term is identity certificate. This is the identity certificate. And if you open the other one, which is CA bundle, this is also another certificate that contains these three guys over here. So I will open these two by side. Open this side by side. This is the identity. This is the bundle. Bundle is the one which verifies all the subordinate CA. This is identity and these are the bundle. So the thumb rule is when you install any certificate, first you need to import the bundle. Okay, so import in the sense you add the bundle, make the trust relation, then you import the real certificate. That will be our approach. So let's see how we can do that. And again, these can be opened in Notepad. I prefer Notepad++. So let me open with Notepad++. This is a certificate bundle, and this is the actual certificate. The certificate here, bundle here. In bundle, you can see, sometimes I have seen in the bundle, there will be multiple entries like begin certificate, end certificate, but here I see only one. Okay, we'll install those. So to install those certificates, this is the command, crypto PKI authenticate. So authenticate, keyword authenticate means you are installing the trust one, that is the bundle. So keep this one here. If you're installing this bundle or importing the bundle, we call it as authenticate. We need to open this bundle in a Notepad++. Bundle is here. Then let me go to the terminal. So I'll click no here because I don't want to see that CSR again. Now let's get into the commands. I will be importing the trust certificate first. The command for that is crypto PKI authenticate trust store. So authenticate and import, there are two commands. Excuse me. So the authenticate will take the trust bundle and add it to the server or add it to the router. So that is what authenticate. Import will actually import the real certificate. Let me authenticate first. The order will be first you need to install the root certificate or the root bundle, the trust bundle, then the actual certificate. They're asking me to copy and paste the root bundle. Usually what happens, the root bundle will be having multiple sections like this. Begin certificate, one certificate, second certificate, and third certificate. But this case, I see only one. So it's okay. Whatever they are giving, you have to go with that. I pasted it here, then hit enter key couple of times. That's it. So you added the trust or you build the trust. Now it's time for you to install the actual identity certificate or the server certificate, which is the real certificate of our cube. Copy this, which is crypto PKI import, and then the trust store name. Edit this one. Now they're asking me to paste the identity certificate, which is this one. So this is the certificate for the device or the server. Adding it here, enter twice. Now it says router certificate successfully imported. At this point, the certificate installation is complete, but we need to say at what communication you need to use the certificates. So in my scenario, when I send a SIP traffic to the router, it has to use the certificate. Or if I send an HTTP request, HTTPS request to the router just to test whether the certificate installation is success or not, it should present the certificate. So what are the occasion you should present the certificate, which I need to configure now. So this one. So if I look at the SIP UA, which is for SIP communication user agent, we should use crypto signaling default trust point. We should use a certificate. This is what it says. Let me copy this command. And now all the SIP communication will be using that particular certificate. But unfortunately, it's not easy to test that. I need to have another entity who can send a SIP traffic. To test our current installation, what I'm going to do is I'm going to enable HTTPS on this router. Then I'll say anyone who accesses HTTPS to the IP address or SBC, send the certificate. Got that command. IP HTTP authentication local will use a local user account to log into the HTTP server. IP HTTP secure server will enable HTTPS server on the router. IP HTTP secure trust point will use this particular certificate when someone tries to access. And this has been already taken care. We have entered this command in the beginning of the configuration. I'll also create one user who can log into the web session. So name admin1, then the privilege 15, password 1, 2, 3. Right? I can use this particular user to log into sbc.ajcollab. I'm going to type sbc.ajcollab. Of course, it is HTTPS. Yes. So this is resolving properly. That's why it's giving me a prompt. Admin1. I logged in. Now I don't want to show what is inside this, but I wanted to see the certificate. So let's click here. Then I can see more information. And this is Firefox. It shows in a different way. That's okay. View certificate. And now you can export the certificate. What is that option to export that here? So let's do one thing. I will open the same thing on Edge browser. Admin 1. Right. So view the certificates and export. Let me save it as like export. All I wanted to show you is when someone accesses the device over HTTPS, it's going to be using the same certificate that we installed. So let us validate that. This is the certificate that CA gave me. I will open that up here. And this is the certificate which I currently exported from the device after the installation. Both will be the same. I will clean this up. This is signed. So how do you verify to certificate? Like we can verify using the certificate serial number. So if you look at this serial number, both of them are same. At this point, the certificate installation is successful. And that's the reason you don't see any warning message here. Usually if you access anything else, you will be able to see if the certificate is not proper, you will be able to see a warning there. Your connection is not secure. Do you want to proceed? Since the SSL certificate was successfully installed, you don't see that particular path. All right. That's it for certificate installation. But anyone who is doing the Microsoft Teams direct routing, we also need to trust few more other certificates. One is the certificate which is used by Microsoft as their CA. They have two particular CSDs, one and then DigiCert one. So we will be installing these two as well. I'm going to be giving the links for downloading those certificates in the description below. You can get that, but I have right now downloaded in my local system. I'm going to open those certificate again inside my Notepad++. This is the Baltimore certificate, and this is the DigiCert. These two certificates are used by Microsoft. So when we establish a secure connection to Microsoft, we should trust these two guys. Then only we can build that relation. So I'm going to be installing the certificate. So install the certificate. You just need to authenticate. Keep in mind, you never import anything. You will be using the authenticate command. For each certificate trust, I need to build a trust store again. So this is the command cryptopk trust point. Baltimore Microsoft CA. That is one of the CAs in Microsoft. DigiCert is another one. For each certificate, I need to have separate trust points. Okay. Also, to install the certificate, we will be using the authenticate command. Okay. Authenticate this particular trust point and then paste the certificate again here. Let's copy this to my device. All right. And I can import the Baltimore certificate. Import in the sense adding that Baltimore into my router. Let's copy this content. Done. Accept. Certificate imported. Now let's do the same thing for the other one as well. DigiCert as well. So PKI DigiCert trust point. I'll copy all together. Sorry. This will not be Baltimore. Authentic. DigiCert. Creating a trust point of DigiCert and then importing that DigiCert certificate. All right, that's also imported. Now we also need to import some Cisco certificate chains. This is again optional, but I do see that a lot of trust certificates are available in Cisco. So this command will import all of them. That is also a requirement for Microsoft Direct Routing. Add that as well. Done. Now, if you look at the certificate, show crypto certificate, which is sbc.ajcollab.com. Where is that? The DigiCert, which is recently added. This is the associated trust point, and this one is its CA, and another one which is the SBC trust store. That is our real certificate, sbc.ajcollab.com, and this is its CA, and that's it. Where is the Baltimore? Baltimore is here. That is all the certificates are there. Now we will be good to integrate with Microsoft Teams. All right. Now the router is ready with SSL certificate. So any traffic initiated to this public IP will be NATed to this private IP. We did that port forwarding in my home router. That will take care of that. And then we installed a certificate. So anyone who tries to access HTTPS outside will be getting a proper certificate so that they will not get that warning. And anyone from outside, if they are trying to send a SIP traffic, secure SIP traffic, that will also use that particular certificate. So in our next series, we will be integrating these two things together. We'll be integrating a SIP trunk towards the cube, and then a direct routing between Microsoft Teams and the cube. That will be in the next session. But as I said, I'll also show you if you have an SSL provider other than the zero SSL, for example, Namecheap, how do I get certificate from Namecheap? Okay, that's pretty straightforward again. Once you have your CSR, which is this, you can always see your CSR there by the enroll command. You enter the enroll command. This will display your CSR. So if your CSR provider or the certificate provider is not the zero SSL, if you are doing it for the real implementation, get the CSR, then go to Namecheap, which is like cheap SSL provider. I do have a certificate which is issued for sbc.ajcollab.com. I'm going to rekey that. Okay. So go to the latest installation, latest active certificate, click on reissue, and then paste the CSR here and click next. They're asking receive an email, and they will select some default emails from our domain name. They do have the DNS verification method, but here I prefer to have the email because email was quick. admin.ajcollab.com. So what they're going to do is they will send me an authentication, a link to authenticate that I am the owner of ajcollab.com. So let's click next and then submit, and we'll wait for that email. Yeah, so this is the email that I have received. Now they're saying click here and then enter this key so that you will be validated that the owner of ajcollab.com. Authentication is completed. Close this out and then go to SSL certificates again. Now this will be, the new one will be active. This one will be replaced. And you can download the certificate from here. I said it will also have again 2 layers. Let me extract and open the folder for you. So actually they are giving 2 formats. One is the actual certificate, which is this one, sbc.ajcollab.com. If I open that, that will be issued to sbc.ajcollab.com and issued by this particular guy. And they also have multiple subordinate CA structure. Okay, so that is one certificate, or the identity certificate, which will be imported. And this one is a bundle. This bundle is in a different format, so I can open this bundle in a notepad file. Like I said, sometimes the bundle will be like multiple certificates mixture. I have one certificate here, another one here, and then third certificate. Now, all you need to do is go to the router, authenticate the bundle, crypto PK, authenticate the bundle, and then paste the bundle. Okay. And then crypto key, import, and the actual certificate, which is this one, the certificate, this one. If you do that, then your certificate will be replaced with Namecheap. I'm not going to do that because we are already in place. A certificate is already in place, but I just wanted to touch base on how to install from a paid SSL certificate. All right. Hope this was helpful. Thank you. We'll see you in another video. Bye-bye.